Okay? So remember, standard equation of a circle, it's the opposite of the coordinates equals the radius squared. So for example, if I was looking at number 4, the opposite of 2 would be, this would be x minus 2 squared. The opposite of 6 would be -6, so y minus 6 squared. And then you square what they give you for the radius. 12 squared would be 144. All right. In number 6 underneath, remember the opposite means you switch your sign. So instead of -5, it would be +5. And when you square a square root, what do they do to each other? Cancel out. You just got 3. All right? Everybody good with that idea? Everybody good with given a center and a point? So for example, if we were looking at number 13, what's the opposite of -4? +4. Good. X plus 4 squared. What's the opposite of -1? +1. So +1 squared. Now you got to get the radius. To get the radius, you use one of 2 things. Either what? Distance formula or Pythagorean theorem. If you want to do it without graphing, you just have to use the numbers. If I look at the x coordinates, -4 and -6, how far is it from -4 over to -6? 2. I'm going from -1 up to 5. How far is it from -1 up to 5? 6. What is 2 squared? 4. 6 squared? 36. 36 plus 4 is 40. You'd end up with a square root of 40. But remember, when you plug it back in, a square and a square root cancel out. I got 40. All right? For people that worry about these things, don't worry about 16. You want to have one with square roots. All right? Everybody good with graphing a circle once we figure out what the coordinate is? So for example, in number 18, what's the opposite of -1? 1. What's the opposite of +5? So 1, -5 is my center. And then 4 represents the radius squared. So to get the radius, we do a square root. What's the square root of 4? 2. So I would go over 2 in both directions. Then I'd go up 2, down 2, and do the best circle I possibly can. All right. The same thing works in reverse, writing the standard equation of each circle. So if I look at number 19, the first thing I do is find the coordinates of the center. All right. The center seems to be at 3, -4. So I got x minus 3 squared plus y plus 4 squared. And then you got to figure out the radius by counting. How far is it going up, down, or across? 2. What is 2 squared? 4. All right. Okay. So now we're in the back. All right. Find the equation of a circle with a diameter. The first thing we have to do is get the center. To get the center, remember, what do I have to find for the diameter? Midpoint. Midpoint is the average, so we're just going to add up and divide by 2. 5 plus 9, 14, half of 14, 7. 11 plus 3 is also 14, and half of 14 is 7. So I got x minus 7 squared plus y minus 7 squared. And now I got to get the radius. You then take the center, which is 7, 7. And you can go to either point. It's not going to matter which. I'm either going to go to 9, 3 or 5, 11. I'll go down to 9, 3. Either way, I'll get the same answer. How far is it from 7 over to 9? 2. How far is it from 7 down to 3? 4. 2 squared. 4. 4 squared. 16. 4 plus 16. 20. And when I square root, they cancel out, brings it back to 20. Good. All right. So we're going to, well, we can do it. All right, we'll do it. Sketch the graphs of each equation, find all points of intersection of each paragraph. So x plus 2 squared plus y squared equals 9. So what's the opposite of positive 2? And since there's no number here, what do we assume that number is? 0. So my center is negative 2, 0. Everybody good with that? And then r squared is 9. What is the square root of 9? 3. So I'm going to go up 3, over 3, down 3, and over 3. I'm going to sketch my circle. Then I'm going to graph negative x plus 1. All right? So my y-intercept is 1, and then I'm going to go down 1 and over 1. I connect them. And I see I have how many points of intersection? 2. 1 there and 1 there. So if I do a graphing, I have negative 2, 3 and 1, 0. All right. Now, the problem is if you draw your circle a little wrong, it cannot affect your answer. Yeah. So we're going to show you the other one doing algebraically. Now, you have this in homework tonight. You're not going to have this on your quiz on Thursday. All right. But this is just to help you moving forward. Because in the fall, you got to take PSATs, and this may be on. What you can basically do is use substitution, which hopefully you did last year when you solved difference of equations. The only difference is one of them is a quadratic. Other than that, the process is exactly the same. So see down here, they say y is equal to x plus 1. That means I can take my first equation and rewrite it. X minus 1 squared stays exactly the same. You okay with that? Plus, the difference is I replace the y with x plus 1. Substitution, just like you did last year. So it's x plus 1 minus 1 squared equals 13. So I'm just using substitution. All right. What's the 1 minus 1 going to do there? Cancel out. But remember, when you square a binomial, x squared minus 2x plus 1 plus x squared equals 13. You have a quadratic, and more on that in a moment when we start going through the package. 1x squared and 1x squared is 2x squared. Negative 2x stays exactly the same. And then I'm going to bring the positive 13 over, and I'm going to have minus 12 equals 0. Are they all even numbers? Yep. So can I cut them all in half to make my life easier? Yep. X squared minus x minus 6 equals 0. Factors in 2. What two numbers go into 6? Subtract the 1, 3 and 2. So x minus 3, x plus 2. What's the opposite of negative 3? So one solution is x equals 3. What's the opposite of positive 2? So x equals negative 2. All right. Now, if it was a quadratic, it'd be great. You have your solutions, but it's not a quadratic, it's a system. And recall from last year, systems, their answers have how many numbers in? 2. One for the x and one for the y. So you have to plug your x back in to get y. Now, you tell me, working smarter, not harder. Are you going to plug it into that one? Or are you going to plug it into that one? That one. So just plug in 3. What's 3 plus 1? 4. So one solution would be 3, 4. And then the negative 2. Negative 2 plus 1 is negative 1. And negative 2, negative 1. So those are my 2 solutions. Again, will not be on your 2-day quiz beginning Wednesday. That's good for you moving forward. All right? Okay? All good? Good? Okay. So let's look at the homework to make sure you're good to go for tonight. All right. So numbers 1 through 4, you just have to find the center and radius from the equation. Everybody good with that? All right. 5 through 10, you're going the opposite. Remember, when you square a square root, they cancel out. 11 through 16, only difference is they're giving you a graph. All good? 17 through 20, you have to graph the circle. All right? It doesn't need to be insanely perfect. You know what I mean? So like if I look at 18, for example, all right, your center is going to be at 3, 5, right? And your radius is 3. Just do something like that, knowing that you understand it's 3. If it's kind of in the right area, I'm fine. All right? Good. 21 through 24, they're giving you a center and a point. We went through those again today. 25 and 26, you're just finding the standard equation. 27 through 29, they're giving you the circle with a diameter. That should be fine. All right, 30, you're just answering, not a big deal. All right, just trying to think of it. 31 through 33, you can either graph them or solve them algebraically. It's up to you. All right, those are for your good. Don't worry about 34. 35 is a nice problem. Don't worry about 36. All right. If we have time after quizzes and all that, we'll go back and do 36. It's a nice problem. I'm not really worried about that right now. So focus on 35. Good? Yes, ma'am. Where all is underneath. There's the G. There's no, if you want to have anyone say less. Right? All good? Okay, so. Quiz 12.1 to 12.5. Wednesday. Okay, Wednesday. 10 multiple choice questions. 12.1 through 12.5 means how many sections? 10 total questions means how many sections per question? All right. Each one worth 5 points. Total of 50 points. Thursday, part 2. 5 questions. In the packet that we're about to go over, how many pages were there? 5. 1 per page. Which means you have 1 proof, means you have 1 problem involving trig, 1 problem involving a quadratic, 1 problem involving a system, and then you will have an angle puzzle from the last page. All right? Okay. I will be after today in the 910 library. All right. For those of you at home, Virtual Math Lab is available with Miss McPhee today as well. All right. Tuesday, I'll be in this room 211. All right. I will have a virtual component as well for people at home. All right. So I'll be after either day. How many people aren't going to be here on Friday? And that they know. Okay. Talk to me on Thursday after the quiz, because I'm just going to give you what we're going to hand out on Friday, and that's all you're going to really miss. Okay, so we're doing something for your summer review topic. So, all right. So that covers everything in preparation for that. Well, let's look at some stuff, shall we? So we'll get rid of that. We'll open up the PowerPoint. Chapter 12, packet solution. All right, so obviously your proof will be fill in. Your proof will be fill in. See? Come on. Go. All right, there we go. Windows P. Duplicate. Chapter 12, packet solution. All right. So, some of the things you need to keep in mind as you go through these. And if you're just jotting down the answers, please don't. I'll have it up momentarily, or if it's not up already, I don't know if I posted it already or not. All right. But try to understand what we're looking for when we do a proof. All right. Obviously, you're looking for radii, because what? All radii are what? Congruent. Tangent lines mean right angles. The difference with this one is you're trying to prove that. Okay, you're trying to prove one of the properties, so that you can't use them. That's why it says it in there. All right. However, you can use all radii are congruent. Make sense? What you can't use is that these make a right angle and things like that. So they would have to give it to you. So basically, they're telling you they're perpendicular. All right, which means you got right angles. As always, or it seems like as always, EG serves as a what? Shared side. You got the radii and the shared sides. You got 2 sides of the right triangle congruent. Double check to see if it's side angle side or hypotenuse leg. In fact, it is hypotenuse leg, and that is the proof that enables us to say that tangent segments are congruent. Okay? Good? Yes, ma'am. Were you absent the day of the sub? Got it. Okay. Obviously, both would have the right angles. All right. With hypotenuse leg, you got one of them's got to be the hypotenuse. And then the leg can be either one. So it could be that one or the top one. If it was side angle side, the hypotenuse isn't involved. So that's the best way to answer your question. If hypotenuse is involved, it's HO. If not, it's silence. All right? Everybody else good with the concepts presented in that proof? Sweet. All right. So, now, one of the major things you look for as we progress through this quiz is whether they cross through the center or not, and they don't. Okay? They don't. They say that because it's circle. All right? They do tell you angle P is congruent to angle J. When they tell you that, when they give you one letter, that is the whole angle. Okay? And then again, you have this figure of triangles on top of each other. Once again, shared side, the difference is they're on top of each other. So PJ is the shared side. All right? Now, H and K. H and K. In here, there we go. Find about it. Probably not. Come on. Come on. Come on. Yeah. Oh. All right. You have to look for that diagram where they're being inscribed by the same order. And that's what's happening there. PJ inscribes both H and K. All right? All right? So that's the idea behind it. All right? And then basically breaking it down, you would then have that angle, those angles, PJ, and since the side doesn't touch both angles, it's angle, angle, side. All right? Any questions about the ideas presented in that one? So what I'm trying to do is a lot of this is visualization. I know some people struggle with that. So looking at the proof, is there something you don't visualize that you're struggling with? Which angle did you use? Which angle did you use? A. Did you draw in like something? Very hurtful. The only problem with that is it has to be radii. They don't have to be yeah, they're not really. It's not really a sound thing. All right. Everybody else good? All right. And then the last one, which hopefully was the easiest one out of all of them. All right. Use your radii, of course. All right. They tell you BC is congruent to BD. So basically that tells you those angles are congruent. Everybody good with that property? These chords are congruent, those angles are congruent. All right? And then once again, a shared side. And then going from there, they ask you to prove that something bisects. So remember from earlier in the year, that is the definition of. Previous step is CPCPC. Boom, shakalaka, we're ready to go. Good. right, the trig. The trig. And this is the part we added on later. I apologize for that. All right. So we then told you that this angle was 65 degrees. All right. And then that segment was a 7.6. The tangent is what gives you the right angle. And from there, you can use trig to get your missing side. Because I'm trying to get the radius, and that's the opposite and adjacent, that's why we would use tangent. The tangent of 65 equals 7.6 over 4. All right, that makes our radius 3.54. And the area is pi 3.54 squared. The sector, they tell you that that's 65 degrees. 65 over 360 times the area you got up there. And then the shaded region out here is the triangle taking away the sector. So you do 1/2, 3.54 times 7.6 minus the sector, and it gives you 6.4. Yes, ma'am.
Where did you get that 4 from?
And that's just an R. That shouldn't be a 4. That should just be an R. That's the equation. Sorry. And I must have misprinted, so put that up. Because that's what we're trying to find. When you set up using trig and finding one of them is going to be the variable, and that's what the R is. Sorry about that. All right, but everything else falls in line. Good. All of it makes sense visually, the processes. The mathematics by now shouldn't be that bad for anybody. All right, then. So the next one, all right. Remember, if they tell you this is 52 degrees and this is also 52 degrees, remember if it goes through the center and that's the midpoint, that's got to be a right angle. We'll go from there. BDF is a triangle. So that's the 1/2, 3.54 times 7.6. Good with that. And then I'm taking away the sector, which I got messed up. So that's all it is. So it's the triangle minus the sector. Does that get you that? Good? All right. Recall. Again, if that's passing through the midpoint, that's got to be a right angle. The arcs and the central angles have to be congruent, so that's why that's 52 degrees. They give you GK is 2.4. So if we use tangent once again, we'll be able to get HK, which is 3.07. Cosine gives us the hypotenuse. Hypotenuse gives us the area. The triangle is the triangle they wanted. GJH, which is this triangle. Remember, that's the midpoint, so that gets multiplied by 2. That's where the 6.14 comes from rather than the 3.07. They give you that as 2.4 and boom. And then remember, a segment is the area of the sector minus the triangle, right? That angle is 52 degrees, so the whole thing would be 104 because that's got to be bisected. So that's why we got 104 over 360 pi radius squared minus 1/2. Base is a 6.14. Height is 2.4, and you get 6. You get that for your
Can you re-explain explain how you got the 6.14?
This is 3.07. Those are congruent. So you just multiply by 2. Good. All right. Diameter, semicircle, inscribed by a semicircle must be a right angle. That's 67, inscribed angle is half of it. That's where the 33.5 comes from. So the cosine of 33.5 is the adjacent, which is 5.4, over the hypotenuse, which is your diameter. All right. If your diameter is 6.5, your radius is 3.25. All right. They want the length of the arc, correct? Which is the length of PQM, which is a semicircle. So that would either be 2 pi r divided by 2 or pi d divided by 2. Either way you go about it. That's where the 10.2 comes from. And then the combined shaded area is the 1/2 pi 3.25 squared. Because the radius is the 3.25, so that'd be the area of the whole thing, minus once again the area of the triangle, which is the 5.4, 3.6. 3.6 can come from, put that right there, one more tree.
Where did you get that?
This angle 67, the arc. Inscribed angles are what fraction of the intersected arc half? 33.5. I think the challenging thing isn't the math. I think the challenging thing is remembering all that. Makes sense? So how everything applies. That's why you want to make a checklist for yourself. Yes, ma'am.
How do you know the angle at the right angle?
How angle what it and is a right angle? If this segment doesn't go through the center, they'll give you another point that is. They're not doing that, so we can assume that's going through the center. That makes that a diameter. Makes that a semicircle. Semicircle measures 180. Half of 180 would be good. Or you just use the theorem again, angles inscribed by a semicircle or diameter or right angle. Good questions from all of you. Everybody good? Page 3, quadratics. That's the difference between that one and the ones you did in the homework assignment. In the ones you did in the homework assignments, what did the squares do to each other? Cancel out. That's what happens when they don't. All right? And basically that occurs when they're looking for this portion of the segment out there. All right? Because if that's 8, that's also what? 8, and then you just use quadratic formula. Not quadratic formula, it's not a quadratic. The quadratic you get on Thursday will be factorable. And if you get one that looks like that, and it's on Wednesdays, then you know you shouldn't have to use quadratic, like the ones. Got it? Where they cancel that. There you go. And obviously, the opposite of positive 25 is what? Negative 25. When we have a length that's a negative number, no. But again, if you see a problem like that on Wednesday, chances are the x squared should cancel out. Good. Because these are vertical angles, these angles are what? Congruent. If the central angles are congruent, so are the what? Chords. All right, so you just set them equal to each other and solve. That one, they both work. So that one doesn't have an extraneous one. Everybody understands? Because if you plug the negative back in to either one, guess what it turns back into? A positive. So neither of those are. How do I get from here to here? Did you do slide and divide lecture? Okay. So you take your leading coefficient, which is 3, multiplied by your constant, which is 35, and you rewrite it. X squared minus 8x minus 105. Okay? Now, because this ends in a 5, the first thing I would check for is 5. So 5 and 21. The problem is, okay, it subtracts to 16, not 8, which is too big, which means I need to make this one smaller and that one bigger. So if I go to 7 and 15, look at that, I got the numbers at 8. All right, so that becomes x minus 15, because the 8 is negative, x plus 7. If you're going to do slide and divide, please don't make the same mistake that so many people, including my children, to my dismay did. You have to bring back the leading coefficient, which is what? Correct. Okay. Now, if you quote unquote have to factor it in your life, does 3 go into 15? Yeah, so that part simplifies down into x minus 5. All right? If it doesn't go into it, you need to bring it back and put it as the coefficient after you reduce. So that's where that part comes from. Okay? Now, if you're just solving like this one, you don't need to do this. You just have to do the opposite of those numbers. So the opposite of negative 15 over 3 is 15 over 3, which is 5, and the opposite of positive 7 over 3 is negative 7. All right? Good? So we'll put up the last quadratic and we'll call it a day. There you go. Oops, that's the wrong diagram, correct? Dang, numbit. Ah, oh, stupid boy. That's not what I want to be showing anybody either. That's the quiz. Let's see. Z. That up. And a little. Oh. I don't even know what it is. There we go. Slideshow from correspond. There you go. All right, because R is an inscribed angle, it's what fraction of the R? F. So you have to remember to take the 3 minus 10x and multiply by what? 2. That's where the 6 minus 20x comes from. And then you solve it. Negative 18, when you solve it, becomes straight. All right, so we'll see you back here tomorrow. We'll go over 12.5, and then we will go over the rest of the packet, which is just these systems and then the angle puzzle at the end, and take any other questions you may have. If you would like to bring your book back, you're not going to use it the rest of the year and want to get it out of the way, you don't plan on using it, bring it in on either Wednesday or Thursday. We'll check it off. Bye, guys. Have a great day.
You're in the National Library today.
Yes, downtown library right at school. I'll be there till 3. Well, be good, guys. Stay safe. See you tomorrow if I don't see you at school. All right. Be good. Hey, so that's okay. Are you taking them today or tomorrow? Yeah, in this room. Okay. All right, Cameron. Let's walk you through this one. So if we're looking at it, okay, they tell us in the problem. All right, I got to present it. It'll be easier if I present it from my screen. Hold on. All right. So basically what they're saying is, well, they're not saying, those are vertical angles. So those have to be congruent. When the central angles are congruent, so are the chords and the arcs. They have to be congruent as well. That's from, I don't think it's 12.4, it's 12.3. I don't remember what it's from. So basically once we do that, we can just set the two variable expressions and set them equal to each other. Since they just said to solve for the variable, we don't have to plug back in or anything. All right, so that would set, and that's where my equation comes from. The 3x squared minus 3 equals 8x plus 32, and then I solve it from there. All right. And then don't worry about these numbers. That's just what you get when you plug it back in. Didn't ask you for that. It just said for you to find out. So these are your two solutions based upon working with the formula. You too, Cameron. Have a good one.